Hello, welcome back to my recorded classes. So, this recorded video we are discussing the module number 1, some of the worksheet questions. Okay, some of the questions we are solving here from module 1 from each section. So, let's start the questions here. First question we are doing from section number 1.4, method of proving theorems. In that module we are studied two proof methods. One is the direct proof method, and second one proof by contraposition. Correct. So here we are doing one question from direct proof method. So first we can see what is direct proof method, how we are doing. In step 1, assume that P is true. That means in direct proof method we need to prove P implies Q. This is what our question. We need to prove P implies Q. That means if P is true, then Q is also true. Correct? So for that, what we do in the first step, assume that P is true. We need to assume P is true. Then in step 2, we need to show that Q is true. That from that we can conclude P implies Q. So to prove P implies Q, what we need to prove? Start from P, assume that P is true. We need to assume in step 1 P is true. After that we need to show that Q is true. Then we can conclude P implies Q is true. So we'll go one question here. For example, question number 1. Prove the statement using direct proof. Prove the statements using direct proof. What is the statement here? If n is divisible by 3, then 3n square plus 6n plus 9 is divisible by 9. This is what our question. So you can see the if statement, conditional statement, correct? If and then means, that is conditional statement, correct? So we need to prove here P implies Q. So first we are writing what is the P here. What is the P here? N is divisible by 3, correct? N is divisible by 3. This is the P statement. Now what is the Q statement here? Q means 3n square plus 6n plus 9 is divisible by 9. Is divisible by 9. This is the Q statement. Okay. So this we have P here and we have Q here, correct? Now what we need to prove here? We need to prove P implies Q. That is what our question, by using direct proof method, correct? By using directly we need to prove P implies Q, because if statement, this one conditional statement, correct? So let me start the proof now. Okay, let me start the proof now. What we need to do in the proof? Assume that P is true. That is the step 1 we need to do. Assume that P is true, correct? So we can go P. What is P actually? P is true. What is P actually? N is divisible. N is divisible by 3, correct? First we are assuming this one. Assuming P is true, that is n is divisible by 3. N is divisible by 3 means what is the meaning? N divided by 3 should be an integer number. That is the meaning. N is divisible by 3. N is divisible by 3. That means n can divide by 3. If you are dividing n by 3, you will get an integer number. That is the meaning, n divisible by 3. So n by 3 will be an integer number. K means an integer number. That means what will be n from here? N equal to this 3 cross multiplied to the next side. So n equal to 3 multiply k, correct? So I hope you understood this one. Assume that n equal to 3 multiply k. That means n is divisible by 3. N is divisible by 3 means n by 3 equal to k. That means n equal to 3k, correct? Now what we need to prove? We need to prove 3n square plus 6n plus 9 is divisible by 9, correct? So we are just starting with 3n square plus 6n plus 9 equal to, okay, just check this one. This should be divisible by 9. That is what we need to prove here in step 2. So 3n square plus 6n plus 9 equal to 3 multiply, just apply the n number here. What is the n number? 3k, correct? We are written here n equal to 3k. So apply here n square, that means 3k square plus 6 time n. N means 3k plus 9, correct? 3 multiply 3k square plus 6 3k plus 9. Now just simplify here, equals. Okay, 3 multiply 3k square means 3 multiply, what is 3k square? 3 square is 9, k square is k square, plus 6 multiply 3, that is 18, multiply k plus 9, correct? That means what we are getting here, 3 multiply 9 means 27 k power 2 plus 18k plus 9, correct? Now you can check all these three terms. What we can take common outside? We can take the number 9, we can take it outside, correct? So 9 multiply, what will be the balance? 27 k square, 9 we are taken means 3k power 2, correct? Because 3 multiply 9, 27, plus 18 we are taken, 9 outside means 2k, plus from 9 we are taken outside means 1 balance, correct? So 27 we are taken, 9 outside means 27 by 9, that is 3. 18 we are taken, 9 outside means 18 by 9, that is 2. From 9 we are taken, 9 outside means 1 is balanced, like that. Okay, so 3k square plus 2k plus 1. So what we got, I will write the next page, that is 3n power 2 plus 6n plus 9. 6n plus 9. When we are simplified, what answer we are getting? We are getting 9 multiply 3k square, 9 multiply 3k square plus 2k plus 1, plus 2k plus 1, correct? Now think about the right side here. Is it divisible by 9? Yes, it is divisible by 9, correct? Is divisible by 9, correct? Because we can divide by 9, that's why 9 we are taken common outside, correct? When we are dividing 9, you will get an integer number, correct? Because this 9, when we are dividing by 9, this 9 and 9 will cancel. So 9 and 9 will cancel. So we can divide, it is divisible by 9, correct? So we can write it is divisible by 9. That means 3n square plus 6n plus 9 is divisible by 9, correct? 3n square plus 6n plus 9 is divisible by 9. What is the meaning of that one? Q is also true, correct? Because 3n square plus 9 is divisible by 9 means that is the Q statement. That means Q is true, correct? Q is true. You understood? So we started with P, assume that P is true, we got Q is true. So what we can say, therefore P implies Q is also true. So this is the proof of that statement, proof of that theorem by using direct proof. Start from P, assume P is true, then just to prove that Q is also true, that means P implies Q. We can conclude P implies Q here. Hope you understood this question. Now we will go to 1.3 section, rules of inference. You know, many rules of inference we are studied. Modus ponens, P implies Q, therefore Q. Then modus tollens we are studied. Negation of Q, P implies Q, therefore negation of P. Then hypothetical syllogism, P implies Q, Q implies R, therefore P implies R. Then disjunctive syllogism, P or Q, negation P, therefore Q, correct? Then addition rule we studied, P or Q. Then simplification we studied, P and Q, therefore P. Then we studied these two, resolution and another rule also. So all the rules we are studied, correct? Conjunction and resolution. Conjunction means P, Q, therefore P and Q. Resolution means P or Q, negation P or R, therefore Q or R. Like, see, so these are the main rules of inference we are studied. So based on, we will do one question we will practice here. You can see, show that the premises. If you send me an email message, then I will finish writing the program. If you do not send me an email message, then I will go to sleep early. And if I go sleep early, then I will wake up feeling refreshed. Lead to the conclusion, if I do not finish writing the program, then I will wake up feeling refreshed. Okay, we need to use the rule of inference and we need to show the premises follows the conclusion. That is what our question here. Okay, so let me convert the wordings first. Just to take what are the P, Q, R, the statement here. For example, P. What is the P statement we are taking? If you send an email message, correct? So we can take you send me an email message. You send me an email message. We are taken as P. Okay, then I will finish writing the program, correct? So I will finish writing the program, taking it as Q. So I can write Q means I will finish writing the program, correct? Then if you do not send me an email message, it is the negation of the P, correct? If you do not send me an email message, it is negation of P. Okay, then I will go to sleep early. That we can take it as R. I will go to sleep early. That we can take it as R statement. I will go to sleep early, take it as R. Now, and if I go sleep early, that is R, correct? I will wake up feeling refreshed. Okay, that is taking as S. So S means I will sorry, yeah, I will wake up feeling refreshed. That we are taking as S. Okay. Then lead to the conclusion, I do not finish the writing program, then I will wake up feeling refreshed. So these are the P, Q, R, S we are taken, the variables we are taken. Now we are converting into the sentence. So next one we are writing. What are the first line? You can see first line we are converting the premises first, and we have a conclusion here. So what are the premises? You can see first one, if means conditional statement. If you message me, send me a message, email message, that means P, then that means arrow, one-sided arrow, conditional statement. I will finish writing the program, that means P implies Q. That is the first premises. Okay, P implies Q. Now what is the next one? If, again if statement, conditional statement. You do not send me an email message. Not means negation. Negation of P, I will go to sleep early means R. So negation of P gives R. Negation of P gives R. Then can continue. I will go to sleep early. I will go to sleep early means R. Okay, that also if statement, conditional statement. If I will go, I go to sleep early, then I will wake up feeling refreshed. That is S. So R gives S. R implies S. Conditional statement. R implies S. Now lead to the conclusion. What is the conclusion? If I do not finish writing the program, negation statement. Not is there. Not. I do not finish writing the program. That means negation of Q statement, negation, correct? Then I will wake up feeling refreshed means S. So negation of Q implies S because it is if statement, conditional statement. So we can write the conclusion here, negation of Q gives S here, correct? Yeah, so this is the question hour. Okay, so we need to prove that one, the premises lead to the conclusion. From the premises lead to the conclusion or not by using rules of inferences. Okay, so I will do this one in the next page here. You can see one by one. So first we are writing steps, step number, and what are the premises or reasons. Okay, so we can write here reasons. Okay, so let me go to the first step. First step, we are starting with the first premise. What is the first premise here? P implies Q, correct? P implies Q. So we can write premises, premise 1. Now, just you can see the second premise. What is the second premise here? Negation of P implies Q, correct? Negation of P implies Q here. Negation of P implies R here. So if you want to use this one, what we need to do now, see the negation P it is starting. So what you do is the first premise, just to take the contrapositive. Okay, so contrapositive of 1, first premise. Okay, that we are doing in second step. What is the contrapositive of the first premise? Negation of Q implies negation of P, correct? Just reverse and the negation. Reverse and negation, that is the contrapositive. So negation of Q implies negation of P. Now after that I am going to the second premise. What is the second premise here? Negation of P implies R. Negation of P implies R here, correct? So we can write the premise, the second premise. Now the second step and third step we are combining now, correct? You can use the hypothetical syllogism. Why? Because you know negation P here ending, here negation P is starting, connected statement, correct? So by using hypothetical syllogism from the step 2 and 3, in step 2 and 3, how to write that one? We will get step 4 as negation of Q implies R, correct? The first and last, correct? This is the first and this is the last, that is the hypothetical syllogism. So negation of Q implies R we are getting. Now next step I am going to step number 5. I am writing the next premise. R gives S. R implies S, conditional statement, correct? This is the premise. Okay. Now again hypothetical syllogism we can use in 4 and 5, correct? Because you can see here R and here R. So again we are using hypothetical syllogism in the steps 4 and 5, correct? In 4 and 5. So what are answer getting in sixth step? Negation of Q implies S, correct? This is what our conclusion. You can see this is what our conclusion. Negation of Q implies S. So we got the conclusion, correct? This is what our conclusion. So premises leads the conclusion here now. Premises, that is leads to the conclusion by using the rules of inference. So our argument is valid here, correct? We have a valid argument here. So this is the use of the rules of inference for proving a statement here. You can see that one. So we can say the premises leads to the conclusion. This is what our question here we need to do. Show that the premises leads to the conclusion. So that is correct. Okay, now next point I want to discuss here, the converse, inverse and contrapositive. What is the meaning of converse, inverse and contrapositive? You can see first the definition here. First we have a statement, correct? What is the statement here? If P then Q. That means P implies Q. This is the original statement. P implies Q, conditional statement. If P then Q, correct? Now what is the converse of that statement? Converse of that statement means just to reverse that one. Q implies P. That is the converse of that statement. Q implies P, correct? Now inverse of the statement. What is the inverse of the statement? Inverse of the statement means the original statement give the negated one. That is the inverse. That means P implies Q. That is the original statement. Give the negation here. Negation of P implies negation of Q. That is the inverse statement. Okay. Then next we have Contrapositive. Contrapositive means converse statement negation. That is the contrapositive. What is the converse statement? Q implies P. Correct? Just to give the negation here. Negation of Q implies negation of P. That is the contrapositive statement. So keep in our mind these four statements. Statement, converse, inverse and contrapositive. So you can see one example here. If two angles are congruent, two angles are congruent is P, then they have the same measure means that is Q, because it is if statement. You can see conditional statement, P implies Q, correct? That means P means two angles are congruent, then Q means they have same measure. Now converse means what we do, the same sentence we are writing in reverse order. That means Q write first, then P write. That means Q implies P. That is the converse statement. That means if two angles have same measure, then they are congruent, correct? That is the converse statement. Now inverse statement, what is the meaning inverse statement? Just the negation of the original statement, correct? Negation of the original statement means what is the original statement here? If two angles are congruent, then they have the same measure. So what will be the negation of that statement? We can write, if two angles are not congruent, see negation, then they do not have the same measure. Do not have the same measure. I hope you understood. That means negation of P implies negation of Q. Just to take the negation of the original statement, original condition. Okay. Then contrapositive. What is contrapositive? Negation of the converse statement. That means negation of Q implies negation of P. What is negation of Q? Two angles do not have the same measure, then they are not convergent, correct? That is the contrapositive statement. So if you are getting any statement, for example, if you are getting inverse statement, from that you can create a contrapositive statement. So what we need to do, you need to know what is the inverse, what is the meaning. Inverse means negation of P implies negation of Q. So from that you can create what is the contrapositive statement, correct? Negation of Q implies negation of P, like that. Okay, so all these statement, whenever you are prepare what is P, Q, okay, and how to negate that one. From negated statement, how to create the original one, like that. Okay, so these examples keep in our mind. Now the fourth one I want to discuss from 1.1 section, precedence of the logical operators. That means the order of the operation, which operation we are taking first. Okay, precedence of the logical operation. So negation is there, okay, and operation is there, or operation is there, symmetrical difference is there, and we have here implication and by conditional, correct? All these statement, which operation we are taking in order. So it is written here in order. Negation will be first, then and, then or, then this statement, then conditional, then by conditional, like that, correct? So this is the order of the order operation. This operation or logical operations in the compound statement, compound proposition, which one will apply first? That is the order of the important. For example, here see negation of P or Q and P. So how we are taking this order actually? When we are doing this one, how we are taking the order? Correct? So first we need to do negation P, correct? Negation is the first preference. Then you need to do and. So Q and P you need to calculate. So I am putting this in bracket because it is together. Q and P we need to take. After that we need to take the or operation, correct? Negation P or Q and P. So this one, see this compound proposition we can write like this one, negation of P or Q and P together, that one in bracket we can write like this one equivalently. So this is the precedence of the logical operator. So this one keep in our mind, which operation we are taking first and second, like. Okay, now we will go to the fifth one. Okay, quantification. So these two quantification, for all, for some. Okay, for all, for some, these two quantification. So from that one question we are doing, let n of x be the statement. N of x be the statement, x has visited UAE, that is the statement, where the domain consists of students in your school. Domain means students in your school. Express each of these quantification in English, that is the question. express each of these quantification in English. For example, the first one, for some x n of x, for some x n of x. So how to write that one? For some, see this one, we know the symbol for some, correct? X means, what is the meaning? X means the domain, the students in your school. N of x means, you know the statement, has visited UAE, has visited UAE. So how to write this one? For some x n of x means how to write? Someone in school, someone in school has visited UAE, correct? Has visited UAE. Hope you understood that one. So how we are doing that one? See, for some x n of x. So this one meaning is someone, correct? Or someone. X means the domain, student in your school. So someone in school, okay, in school. X means the students in school. Someone, some students in your school. N of x means what is? Has visited UAE, correct? So hope you understood how we are writing in English. Now next one, see, for all, everyone, for all. So everyone, I am writing everyone or for all. X means the students in your school. So everyone in your school, every students in your school has visited UAE, correct? So everyone in the school has visited UAE, correct? You can write the sentence in your own way, but it should be logically equivalent. For example, if you are writing for all students in your school has visited UAE, that is also correct. Okay. Now the C part of the question, negation of for some x n of x. So when you are writing this statement, see, negation of for some, negation you need to give this for some symbol, negation you need to give n of x also, both. Okay. So negation of for some means, what is the meaning? No one, correct? No one in the school has visited UAE. No one in the school has visited UAE. Or negation of for not someone in school visited UAE, that is the meaning, no one in the school has visited UAE, correct? You can say like this one, no one, negation of someone, no one in the school has visited UAE. That is the statement we are getting, that one. Okay, now question D, for some x negation of x, for some x negation of x. For some x means, what is the meaning? There is someone, correct? There is someone, some of the students, someone means some of the student in the school who has not visited, negation of n of x. Has visited UAE is the n of x, so negation means has not visited, who has not visited UAE. Okay, equivalently you can write your own way also. Okay, how that sentence is coming, you can write equivalent statement also, no issue. Now question number E, negation of for all x n of x. Negation of for all negation means not everyone, correct? Not everyone, you can see negation means not, all means everyone, not everyone in the school, not everyone in the school has visited UAE, has visited UAE, we can say that one. Or it is same as D only, see, same as the D statement. D and E are same, because here negation we are applied in D statement. So we can write like that also, there is someone in the school who has not visited UAE. See, for example, negation of for all means for someone, there is someone, and negation of n of x means has not visited UAE, that is same as the D statement, that also correct. Okay. Now question F, for all x negation of n of x. For all x means everyone, correct? Everyone in the school. Everyone in the school. Negation of n of x. That means has not visited UAE. Has not visited UAE. So that is the question here. So more question we are done in another recorded class. You can refer that also. So here I am giving some examples only regarding for all and for some quantifications. Okay. Now we will go to the that's it, that is concluding this module. So 5 different question we are discussed here. Out of these 5 questions, these are the questions mainly coming in module 1 related questions. So you can practice more questions. Already recorded classes are there available. So hope you understood this recorded class. Please subscribe my channel for getting more recorded classes. Thank you very much.